you are able to visit, visitable, able to visit. So we have a visitor and a visitable, the thing that's visitable. We have the thing that's doing the visiting and the thing that's visitable. That's basically it. So let's say our problem revolves around shapes, right? So we have shapes that we don't want to do drawing, we want to calculate the area. So they have a similar function operation, right, which is calculating an area. So since they have a similar operation, and that operation is kind of unrelated in the sense that to calculate the area for a rectangle is not the same way as you calculate the area for a circle. So yeah. So what I'm going to do is I'm going to do this. I'm going to write the plan here. So we have the shapes, right? So we have shapes, and these shapes are that I'm gonna use is circle, rectangle, and a square. And then if you remember the area for a circle is pi r squared, right? So pi times r squared. And then the area of a rectangle, you have two lengths and two widths. So it's basically what you're supposed to, when you're supposed to what, they're supposed to add them or what. I'm very bad at maths. I'll come back to that. And then the length, you have four sides that are the same size. So you can just say length times 4. Or you can just add all of them together, which is just 4L, right? Just 4L, basically 4 times the length, because all four sides are equal. That's a square. And then this one, oh yeah, I think it's like this. This one is 2 times the length and then plus 2 times the width, right? So this will be the areas, right? So I'm gonna actually create a function called, I'm gonna call it get area, and we're gonna actually create a function that calculates the total area. We still have get to area, but then we're gonna have a total area just to make it interesting so that you can see the full picture. So if I'm not sure if I should actually demonstrate a bit of UML before we start. I think I should. Draw. Conjure, what's that thing? Not draw that I. What is it called? Dia. So I'm gonna use Dia to demonstrate. So remember what I said, we have a visitor and a visitable. There's a thing that's doing the visiting and the things that we're able to visit. So that's basically the main concept of the visitor design pattern. So the way it works, the proper way of designing UML, because remember, we want to be able to add new operations without making changes to the existing classes. So the way they go about doing it is you create an interface that represents your abstract visit, right? So abstract visitor, right? It depends. Remember, they say that you should remember when you're looking at that's why I did the theory first. They said you should try and apply your design pattern to your problem. So don't actually create a class called abstract visit. There's no such thing as an abstract visit. You should actually, since I'm dealing with shapes, you should actually call it shape visitor. But I'll only implement that inside of my Eclipse in code. So for now, I'll just do it in UML. So there's no attributes that we're gonna pass. We're only gonna pass in operations. So this is a visitor, right? I want you to understand the terminology. It's a visitor. What does the visitor do? He visits. So we're going to have a visit function. And the way the design pattern works is that you're going to have multiple visit function, and then you take in the parameters of the things that you are visiting, of which they are not the abstract ones, they are the concrete ones, because you cannot visit something that's incomplete, which makes sense because you can't go visit your friend who stays in an accommodation that does not have all the facilities. For example, let's say it's cold right now, right? And you want to go visit Chomi. If Chomi doesn't have a heater, let's say that's how strict you are. So basically, that means Chomi's room is incomplete. It's abstract. So obviously, you can't visit something that's abstract, that's incomplete. You must visit only something that's complete. So we're gonna call the function visit, and it's going to be void. So you might ask yourself, why do we need the interfaces? The interfaces are just used to declare. It's like abstract base class. I get it, abstract base class. And remember, we're avoiding repetition. We need interfaces because interfaces they're similar. Remember, there's in semester test 1 year the question whereby you're supposed to compare between an abstract base class or an abstract class and an interface because they're actually similar. The difference is that an interface, you can't implement the okay, you can't necessarily okay, technically you can, but not really. You can't have functions that are implemented. The implementation that you can put is basically default code, which is still like constant. Unlike an abstract class, it can have two types of methods: instance method, and you can also have static method, and you can also have abstract methods, whereby an interface mainly has abstract methods. So visit, we pass in what we call a concrete visitable. So you pass in all the things you're visiting. So if you're visiting 3 things, you're going to pass in 3 visit functions because you need to visit that specific entity or that specific class or that object. So I'm going to call it obj circle. Then I'm going to pass in the type. Okay, remember we're not passing. Yeah, let me not pass. Let me not make it specific. I'm going to make it. I'm going to actually write it as sort of like a template. So this will be concrete visitable. That's the first function. And then we have another one, visit void takes in. This will be object 2, takes in another concrete visitable, right? We're gonna have multiple visitables, visitable 1, visitable 2, and so forth. But I'll just call all of them concrete visitable. Don't think it's the same visitable. I'm just putting it there because I'm trying to model the way it looks on your slides. So this will be object 3. But then I'm modeling it whilst applying it to the problem, if you can notice. Concrete visitable. Yeah, so it's 3 because I have 3 shapes that I'm visiting. And then okay. Then I have my abstract visitor. Obviously, since they're abstract methods, I need someone who's going to do the implementation, which is what I call the concrete visitor. To be honest, this is actually one of the easiest design patterns. Okay, maybe there's other easier ones, but this is actually quite fairly easy. If you can pick up where to apply it in the question paper, if that's the way you should apply it. If that's where you should apply it, then you should apply it. Then you're gonna have what I call a concrete visitor, which is gonna contain the implementations, right, of these visit functions. So apply. And then since it's gonna basically it implements, remember it's gonna implement all of these functions. So it also takes in all those functions. So I'm also gonna have all the 3 functions. So visit void object 1 concrete visitable, and then a second visit method, and then object 2, and then the concrete visitable. By concrete, we mean a class that has no abstract methods, meaning it's complete. That's what concrete means. And then object 3, concrete visitable. And then done. Then this it is here. So this will be an interface. We're going to actually do realization. Where is it? Here. So this realizes this interface, right? And implements all these 3 functions. Then since we have the visitor who passes all the visit functions, basically all the things is going to visit, and we visit them via visit functions. Then we also need the things that are visitable, the things we can visit, or basically things we are able to visit. Hence the word visitable. If you separate the words visit and able, basically means things we're able to visit. This is how I'm able to kind of come up with definitions on the fly without having to think hard and be like, look at the dictionary, because you can split up any English word and kind of have kind of come up with your own definition through inference. So let's create the visitable. Obviously, for the sake of design purposes, we're always going to have a base class or an interface. In this case, we're using an interface because there's only abstract methods. So I'm going to create what we call an abstract visitable. So abstract visitable, which takes in, so remember, this is the person who's visitable. Basically, the person you are able to visit or the person you are visiting. Since you are visiting that person, you need to accept your visit. So I'm going to pass in an accept method, of which is also void. And then the parameter is the abstract visitor, the person who's doing the visiting. In this case, is the abstract visitor. So I'm going to call him visitor, abstract visitor. And then done. That's basically the interface. Then we're gonna have things that are visitable because remember it serves as like the base class, even though it's an interface. It serves like the base class. What I would do is, right, I'm gonna put in what we call the stereotype here so that you can see whether the thing is an interface or not. So I'm gonna say that's an interface so that it reads like an interface. Okay, my bad. That means I don't have to. It's gonna put the symbols automatically, so I don't have to put them here. So that you see these are interfaces, and then interface, and then apply. Okay, yeah, everything adds up, right? Don't be impatient and you want to see code. We need to understand it from the design perspective first, because if you check the past papers, they also ask you about design. So don't be a person who's too impatient. Let's start with the design. So concrete visitable. Let's say visitable one. It's fine. Yeah, I'll make it concrete visitable one. Yeah, with the literal one there. And then obvious, since it's going to implement this interface, it's going to take in the same function. So I'm going to say new. It's going to take in accept method, void, and it is a visitor of type abstract visit. And then apply, done. So since we have three methods or three things we are visiting, three visitables, that means I also have three concrete visitables because as you can see, we visit concrete visitables. So, and there's three of them, so I must put three. So 1, 2, and 3. Right. And then I need to simply change this from 1 to a 2. And then you're done. That's basically the design pattern. Yeah, that's basically the design pattern. The UML of the design pattern. I'll send you the diagram. I'll make sure I save it. And then here, and then come on, put it there, and then put it here. And this the here design thing is really kind of annoying. Yeah, don't worry, we'll implement all of the code. The thing is, I need to start with the design first. Because that's how, for example, imagine if builders, they started building the house and then they keep on changing along the way. They're like, oh, maybe we should have actually put the toilet there. So let's destroy everything and then start afresh. Imagine if they had to do that. That's why they start with the blueprint, with the design first. So obviously, when they're trying to train you guys to do the same, because when you get to final year, especially if you're doing informatics, trust me, the diagrams get worse. So get used to UML. UML should be your best friend, even if we all don't like it. It should be. So it's not done yet because remember, this class over here, it takes in an abstract visitor. So that means there's a relationship here. What relationship is that? It's association. It's associated with that class. So where's the association symbol again? It's not the one. Is it that's realization? Where's the association? Yeah, there it is. My bad. So this class over here is associated with this, but then I need to redirect the arrow from B to A. Or from A to B. Okay, I didn't use do association that much. I would just put it in my UML shame. I didn't even understand what was going on there. So this is associated with this because it's used there. Yeah, I think this is the direction. So this will be the diagram that we're gonna look at. Right. So let's start coding. Gonna start with an abstract visitor. Remember, you need to apply it to your solution. In my case, I have shapes. So instead of abstract, what is this? Abstract visitor, I'm gonna call it shape visitor. So let's create that. So file and then new Java project. So this is visitor, design, pattern, example, code. Right, I'm gonna store it in the default location. Make sure you don't choose module info.java or else it's gonna crash. And then next, and then there's nothing else to choose here, and then just click finish. And then I'm going to expand this and then right click here. You don't have to worry about packages, right? Don't worry about packages. This is not a prac. It's just an example. If you want to do packages and all those things, that's up to you. Me, I'm not going to do that because this is just an example. So I'm going to start with my main class. The main class, right, is basically if you understand the main class's role, it's basically the class that uses other classes. So a class that uses other classes, we call that the client. My client is basically the person who's using the system because those classes, they actually represent our app. So we can technically say the main class is a client. By client, it's like, for example, for example, you guys, when you log in on Ulink, you guys are clients. Basically, you're the ones using the system, which is that Ulink website. You are the client. In this case, main class uses my code, so it's going to act like a client. So let's create the visit, right? Let's start with the concrete visit. Remember this UML diagram, right? It's not necessarily complete, but it's still complete. You might have more than one concrete visit. In this case, that's a rare, but if you look at the design in your slides, you can have more than one concrete visit. In this case, we're gonna have one. So I'm gonna say new class. I'm gonna call it shape visitor. Right, and not class, my bad. What am I saying? It's an interface. So right click new interface. It's called shape visitor, right? And then generate comments because we need Java doc. So yeah, let's create all the classes one by one, right? So that I don't have to keep on looking at this. So let's create all of them. So I need the concrete visitor. So the concrete visitor is a class, remember, because it implements an interface. So it's a class. I'm gonna call it concrete shape visitor, right? Because I'm applying it to my problem. I don't want to call it, if you just leave it as um, concrete visitor, it's not gonna be applicable to my problem because it doesn't refer to my problem. But to actually take it a step further, you can make it, instead of concrete, you can remove the word concrete and put a name of basically what our problem is based on. In my case, it's based on an area because I'm going to calculate area. So I'm going to call it area shape visit because I want to apply it to my question or to my problem and not just and not just code like I'm using a template. No, I need to apply the template to my solution. So therefore, even if you go back to the sessions we've had before this, I was trying to reiterate on how much you're supposed to apply the design pattern to your problem, to your solution. Don't just call it concrete visitor. No, it's not just concrete. That is just the template. Update it to be applicable to your solution. Then you need an interface for the visitable, right? Which is abstract visitable, right? But then instead of abstract, I'm going to say shape because I'm dealing with shapes. So shape visitable, which is the shape that's visitable. It actually kind of reads, I think yeah, the way I'm naming it kind of makes it simpler because it's shape visible basically means that which shapes are visitable. And then we're also gonna have the classes, which is all the shapes that are visitable. You could, right? I'm gonna reiterate, right? Remember, you need to apply this design pattern to your solution. You don't have to say concrete visitable, circle or circle visitable or whatever. You don't have to put the visitable. You can just put the actual names of the class, because remember the class is basically the way you name the class, you name it based on the thing it's trying to represent. For example, circle. You could put, it's up to you to be honest. You could say circle visitable, but I wouldn't advise that, because anyone who's looking reading your code, they can understand when they see keywords like visitor, visitable, they can understand, oh, it's using the visitor design pattern. So you don't have to be that direct. So I'm just gonna say circle, generate comments, then I create the two other shapes, and then we should be done with all the classes or with the whole structure. So this will be a rectangle. Generate comments, and then, oh, my bad, I forgot, my bad, I forgot. Remember, all these three classes, they implement that interface. I forgot, but it's fine. I'll type the implements myself. I won't, I don't have to worry about that. We'll do that when you get there. And then square, and then generate comments, and then I'm going to minimize this. So these are all the classes we need. So let's start in main. I need to do my Java doc. So at author, Vortex Academy, add version. What version? What are we doing? It's a visitor design pattern code example. I can also put the year 2025, and then I just need to put this in all of my classes, because remember there's marks for Java doc. You can't lose free marks, and you can also tell Eclipse to generate Java doc for you. So that shouldn't be too much of a hassle. And then paste here. Yeah, I guess we'll see how many design patterns I can do. I guess I'll only focus on the design patterns that are there on the past paper. So we're gonna do those three past papers. Those are the design patterns I'm gonna focus on. And then remember we talked about the interface, that all the methods are abstract, and it's actually optional. You can omit the public and the abstract keyword, but by default it's public and abstract. So I'm just gonna say void followed by the method, because remember this is the abstract visitor. In this case, I've applied it to my solution for shapes, since I'm dealing with shapes. So I've called it shape visitor. It takes in all the things we want to visit, and they're passed via the visit function. So I want to visit a circle, because that's the concrete visitable. So circle, and then void visit a rectangle, semicolon, and then void visit a square, square. Right? So that's basically how simple it is, man. It's very simple. So you have this visitor, right? Which has the things he wants to visit. And then the area, remember the area shape visitor, that's where we actually implement the visit methods. So I need to actually just come here and say implement shape visitor. And then it's going to force me to override the methods. So add unimplemented methods, which is basically visiting all the shapes. So before we get to that, this is simple. This is like the last class we'll do. So let's start with the visitable, which basically takes in a function called accept, which accepts the visit from the visitor. So therefore I need to pass in a visitor here, but then I've applied it to my problem. So it's actually called shape visit. Shape visit. And then visitor, then done. That's how simple this interface is. And then all the concrete visitables, they need to implement the abstract visitable. So which is shape visitable. So implement shape visitable. because that's the shape that we're able to visit. It's a circle. And then we do it for all the other shapes. Yeah, it's actually not too bad. You just have to study, that's all. So shape visitable, and then add, and then here implement shape visitable, and then add. It's up to you, right? Whether you want to add accessors or mutators, all those things, that's up to you. So let's start with circle. I know circle, it only needs one value, which is a radius. So I'm going to have private double radius, right? And then I could have a constructor to initialize. I could do that. But for the sake, let me think. Yeah, let's put a constructor there. So public circle takes in a double radius. Because remember, these are classes, they're still classes. We're just using design patterns to avoid so that when we want to add a new shape, we don't affect or change anything in our system. So this will initialize this class's radius with that radius that I'm getting from the user. Then the radius has been initialized. Then we need to have the area method. I'm not going to worry about accessors and getters, accessors and mutators. I'm not going to worry about that. I'm only going to worry about calculating the area. So I need a function called calc area or get area. You could call it get area or calculate area. Let me call it calculate area. So calculate area. And then it returns the area. So it returns some area. So let me declare the area here. So double area. I initialize it to 0.0d and then return area. Then Java doc. And there's quite a lot of typing here. So what's the area? The area is simply saying area is equals to, I'm actually being a bit extra here. You could honestly just simply remove that and just return the area. So area is pi r squared. So I need to go to the math class to extract the constant pi. So math.pi times radius squared. Radius squared, you can do it in multiple ways. You can, for example, what is this? You can multiply the radius by itself, basically radius times radius, or you can say radius squared. So I'm going to show you the other technique. So to say radius squared, you need to call the pow or power function. So the pow, which takes in the first argument is the base. The second parameter is the exponent. So base is radius to the power of 2. And the parameters are double, so you must pass a double. So to the power of 2.0, not just 2. 2.0d. I'm just putting the d there, just confuse those students who don't read the textbook. Then, yeah, so we need to accept this visitor, which is this visit over here, so that now he can do the visit. So now the visitor can visit me, or in other words, can visit this class. So that's why I'm going to pass in this keyword. So if you notice, I'm going to say visitor dot visit, and I need to pass in a circle, which is myself. So visit me. Yeah, I'm accepting this visitor. Then after it has been accepted, it does the visiting. Obviously, you need to pass in the function, the person you want to visit. And remember, if you go inside the shape visitor, we have all of this, right? We visit a circle, we visit a rectangle, we visit a square. Yeah, so that's basically the class. It's done. That's pretty much all you have to do. That's the class. Then we now have to go to rectangle. We do the same thing. So it's quite straightforward. So private, let me use int. Yeah, so int length, comma, width. And then I'm going to create a constructor. So public rectangle, which takes in a length and a width. Right, and then Java doc. And then this dot length is equals to length. And then this dot width is equals to width. Like I said, there's no need for accessors. So I'm gonna actually create a function called calculate area. But do you see that? Do you see a problem here? To be honest, there's still a problem here to a certain extent. There's still a problem. Because do you notice something that I'm about to do, right? I'm about to declare this function again called calculate area, which is not something I should be doing. I shouldn't repeat myself. So technically, if you wanted to, you can also add a calculate area inside this interface. Remember, you apply the interface to your problem. It doesn't mean that it should only have accept method. It just means that at the minimum, there should be an accept method. In this case, I'm gonna repeat this function called calculate area, but I don't know what to write in the base class, so I'm actually gonna make it abstract, meaning I won't provide implementation, basically forcing the child classes to implement it. So I'm gonna have let me see. Okay, it's technically different, technically. Yeah, let me not complicate because remember this is supposed to return a double. Other classes they can return different types. So that means I actually have to use generics, which makes things more complicated. I don't want to do that. So let me not put it in the interface, which is basically the base class. So let me do that. So it's fine. I'll declare them separately, but don't do this. This is not advised. Calculate area, Java doc, and then we return the area. So the area is 2 lengths plus we add up the 2 lengths plus the 2 widths, basically 2 times 1 length, because remember a rectangle, two sides are the same size. So you have the length, which is the same size on both sides, and then we have the width, which is the same size on both sides. So basically, I'm going to say 2 times. Since I'm using integer, I'll just multiply with an integer. So 2 times length plus 2 times width. You don't have to put the parentheses or the brackets, but I just like to put it to make my code easy to read and understand. And then this needs to do a visit. So now I visit this rectangle. So visitor dot visit this, which is me, myself, the rectangle class. And then done. Then we have the last thing. Then we'll be done. So private int length. And then public square takes in the length. And then Java doc. And then this dot length is equals to length. And then we have the function that calculates the area. Since I have an integer, I'm going to get back an integer. So this function should return an integer. And then return. It's up to you how you can calculate the length, to be honest. That's up to you. Remember, the length is just basically adding up all the lengths, which is 4 of them. So you can add up all 4 of them separately, or you can just say 4 times one side. So I'm just going to use 4 times one side. So 4 times one side, which is length. Or you could say, nah, let me not use that method. It's fine. That's not complicated. And then here I do the visit. Since this class accepts the visit from this visit, then now you can visit this class. So visitor dot visit a square, which is this class, because I'm already inside the square class. Excuse me. Then we are done with everything, right? With all the classes. Now we need to do main. Let me just double check. Oh, we're not done. My bad. We're not done. Yeah. So this class is called area shape, right? Basically, this class is going to act as a concrete visitor, right? Which in this case will just simply store the total area. That's what it will store. So I would actually create a variable called total area, of which I'll make it a double because one of the areas is of type double. So double accommodates both integers and doubles. Why do I say so? Because remember 1.0 is just 1. So yeah. So we can using the double data type, we can store both areas. So I'm going to call it total area, right? And then I could put the constructor, or I can decide not to put it. In this case, I don't initialize the area, the total area. It's not necessary because it's supposed to calculate. I could, okay, let me just do it, but then there's no need, to be honest. Let's just put it. So area shape visitor, but it's going to be a no args constructor, basically no parameters. Then I'm going to initialize total area is equals to 0. Like I said, there's really no point for this. It's basically too simple. So this is no args construct. It has no parameters or arguments. And then we need to visit this circle. So this is the concrete visitor. So basically we need to implement the visit methods, right? Since they take in the things that we want to visit. So these things that we want to visit, they have areas. So we're gonna get their areas and we add them into the total area variable, which is basically this. So let's start with circle. So total area plus or equals to this circles dot calculate its area. So it's going to calculate the circle's area and then adds it up to this total area. Because this total area, hence it's called total area because it calculates the total area for all the shapes. Then we do the exact same thing for the other classes, other functions. So, but then this time around it's a rectangle dot calculate total area. And then this one is total area plus or equals to square dot calculate total area. And then we are officially done, right? Now we're left with the main. Basically, to use this design pattern, that's what we are left with. So now I'm going to go to my main, right? So this is my main. So in my main, I'm going to need, let me see, because I need to calculate the total area, abstract visitor. Let me check something here. Just give me a sec. So we have the visitable, which takes in the visitor. So yeah, so I need to actually instantiate this. You see this visitor here. I need to instantiate him because we want to use him to calculate the total area, right? So this is the first thing that I need to instantiate. It's the visit. So abstract visitor, we're going to call him visitor. This goes to new. And we want the concrete one because remember the abstract one, you cannot instantiate an interface because it's an interface, it's not a class. So that's why we chose a concrete visitor. So after we've instantiated the concrete visitor, so here it's instantiate a concrete visitor. Then here we also instantiate our concrete visitables. If you notice something inside the main, right, you only work with the concrete things, which makes sense because it's concrete, it's complete. So I'm going to instantiate all because there's more than one. All concrete visitables, right? So we're gonna just make it 3. We can just make it 3. So what I would do, right, since there's 3 shapes, remember they're all shapes. Basically, they're all of type shape visitable. We could just call it shape, to be honest, because they represent a shape. I just put that visitable to just make you understand, but then don't do that when you write the design pattern. Don't put visitable. To be honest, you shouldn't even put keywords like visit. They shouldn't be there at all. So you need to be very, very careful of that. They shouldn't be there. So we have the shape visitable. So remember all these instances, right? They're all of type visitable, shape visitable. Because remember what I said, interfaces and abstract classes are exactly the same thing. So in this case, an interface, we can view it in this example as like an abstract base class. So it's similar to an abstract base class. So what I'm going to do, right, I'm going to say, I'm going to create an array list of shape visitable. To be honest, you don't have to do this. I'm being a bit extra. You don't have to do this. I'm being a bit extra. So let's, okay, before I continue, we need a way to get the total area. Where's here? Remember, we calculated the total area. We need a way to get it. So what I could do, right, there's two ways. ToString, or you create a function called get total area. That's up to you. I would prefer to use as ToString. So at override public string ToString. So we create a string representation of this object of this class, which is basically simple. I just simply return the area. So I'm going to say total area, right? And then I'm going to use the the format specifiers, right? So I'm going to say, and it's going to be in double so I can round it off, which is good. So I'm going to say %.2f, round it off to 2 decimal places. And then I'm going to say dot formatted, and then I pass in the variable that's going to be put in place of this format specifier, which is the total area. And the data type needs to match. If you use f there, that means it expects you to pass a float, a variable of type float or double. In this case, I passed double. And you can also put in \n, which is %n. Yeah, I think that should be fine. Then let's go back to our main. And then, to be honest, like I said, this is really not important. To be honest, it's not really important. But then I just want to demonstrate quite a lot of stuff here. Let me also create the string. Let me actually create two string functions for all the visitables, because I want you to see the total area that it adds up. That's the whole point. So I'm going to have it override, because remember, these are complete classes, which simply have an extra thing called the accept method. So, but then they're still classes, of which, if you remember, when you're doing file handling, most classes have the toString method. So that's why it's actually mandatory to have it, so that you can see a real world application of the design pattern. So simply use the same syntax. So I'm going to say this is a circle space, and then access modifier. So since it's a circle, my radius is a double, right? Or not the radius, the area is a double. So I'm going to say dot 2f, and then %n dot formatted. And then I pass in the area, right? So which is calculate area. So calculate area. Yeah, and then I pretty much do the same thing for all the other classes. So there's nothing much that's gonna change here. I'm gonna go inside here and simply rename it to rectangle. Yeah, nothing much changes, because I have to call the calculate total function in all of the classes. And then square. Yeah, so now we go back to our main. So I'm gonna have visitables in plural, instantiate to a new array list. Right, and it's gonna force me to import. So let me import them. Yeah, if you have this error, I've noticed Eclipse these days it has this error. Do you see after importing it, imported in the line above where I've wrote the code, which is wrong. Simply use your common sense. Where should it be? Where does it belong? At the top. So I'm just gonna simply cut it and put it at the top. Yeah, if you make excuses like, yeah, Mara, that's not my fault, blah blah, lecturers don't care. So their feelings are actually not, yeah, they're actually unfazed by how you feel. So it's either you do it or you don't. So if you have those errors, yeah, it's life. Eclipse is like that. So you need to find ways to deal with them. Then now I create remember, I need to instantiate all the concrete visitables and add them to my visitables array list. So I'm gonna add all visitables to my list. But the way I'll do it, right? I'll create the visitable and then add it after creating it. So let's start with the circle. So circle is equals to a new circle, of which I think you're supposed to pass in the radius. Yeah, so it's supposed to pass in the radius. Let's say it has a radius of, I don't know what radius to use. Let's say 56.0D because it's the double. And then now I need to add that visitable, which is a circle, into my list. So visitables.add, right? Because even though I use the type shape visitable, it will allow you to add because a circle is a visitable. Like I said, interfaces, they work like a base class. So they still basically we're doing inheritance when you implement an interface. Then I need to instantiate another visitable, which is a rectangle. So rectangle is equals to new rectangle. And then we add that rectangle. But then I need to pass in the parameters, which is length and width. So let's say it has a length of, I don't know, I'm just choosing random numbers, 42 and 88. I don't know. And then the last one is square. So square is equals to new square. All sides are of size 50. Just use 50. They're of length 50. And then I need to add it into my array list of visitables. Then now, since I have an array list or a list of visitables, I go through all the visitables, right? Yeah, I need to go through all of the visitables in the array list, which is going to be of type, yeah, they're of type shape visitable. So I'm gonna go through all of them. So for each shape visitable inside visitables dot, yeah, visitables, not dot. What am I saying? Yeah. So we're gonna go through each visitable inside this list of visitable. But remember, they're actually of all of type shape visitable. So that means we've basically, if you still remember informatics, it's basically upcasting. So we've upcasted them. So now we must actually do what we call downcasting. Since they're all stored under the same type, which is of type of the base class, there's certain functions or certain things that are only existent within that class. For example, radius. For example, calculate area. They're only existent within the class circle. So to actually be able to access those things, we need to actually cast. So we need to check what instance is it. Basically, is it a circle? Is it all those things we need to check? So if visitable is an instance of a circle, then I know I've found a circle. And then we cast to a circle. And then else if visitable is an instance of a rectangle, basically it's of type rectangle. Then else if visitable is an instance of square. Then yeah, so after we found, remember it's still of this type, we need to cast it. So I need to say circle, then create a circle is equals to cast it to a circle, and then what am I casting? The visitable, because I found a circle. Oh, remember I've already declared something of type circle. So I'll just name them C, R, and S, right? C for circle, R for rectangle, and so forth. I'll just name them like that. So copy this, simply repeat that there and change those types. So you need to be very quick. You need to be able to change codes. As you can see, that I'm using my experience to be able to change the code quicker and type faster. It will look like you're typing fast, but not really. You just have techniques. So we have all the things that are visitable, and we have the visitor. Remember the area of the visitor, we need to visit. So I need to call the visit methods. That's why I actually created an array list to kind of save myself time. So I need to visit, right? So remember, we have our visitor. We declared it. There it is here. So our visitor needs to visit all of them. So visitor, so that we can so that we can calculate the total area. Remember, so dot visit visits the circle, so which is C, and then visitor dot visit a rectangle, which is stored in the variable R, and then visitor visits a square, which is stored in the variable S. So it does all the visit. Remember, every time it visits, it takes the current area and then it adds it. It calculates the area for that specific thing we are visiting, and then adds it to the total area that we have currently. To be honest, right, technically you don't need this toString. You could have made this variable over here a static variable so that you can call it without calling without instantiating, but it's fine. It's up to you how you want to solve the problem. So now we are done going through all the visitable, right? So here we basically visit all the visitables in order to calculate total area. Remember the concrete visitor. In this instance, we are using it to calculate only a total area. So in order to calculate the total area. So remember, in order to calculate the total area, we need to visit all the visitables. So that's why I'm visiting all of them. And then once I'm done, I know that the total area has been calculated. Display the total area. You could, remember, we created toStrings in each of the classes, right? You could, if you wanted to, each after visiting each visitable, you print it. It's up to you. So that I just want to print it so that you see that the total area that I'm gonna get is gonna add up if you add the areas for each shape manually. So I'm gonna say this out. Remember, the print line method, it automatically calls the toString method of an object if you're trying to print an object. So you don't have to explicitly call the toString method. So I'm just going to say C. Remember, C is a circle, so print the circle, of which is going to call the toString inside the circle class. And then same applies for R, which is the rectangle. And then S for square. And then we display the area. And then the area, remember, is we created a toString method inside shape the concrete visit, because that's the purpose of the concrete visit. It was just to calculate the total area. So the concrete visitor is stored under the object named visitor. So I'm just going to simply print visitor there. And then that's the full code. Let's try to run it and see if we have any errors. Yeah, we have some errors. What's going on? What did I, oh, it's the format. What format? Okay, let me try to fix the error. Let's see. Oh, my bad. I see the problem. I got the problem. I'm using the wrong. It says copy and paste. It's not %F. It's %D because they're integers or decimals. So D stands for decimals. So %D. My bad. So %D. Yeah, it kind of takes a bit of time if you don't have experience in coding. It takes time to figure out where the error is. So if you try to add up these numbers, right? Let me try to add them up manually myself. I know it's annoying. It's like all of that effort just to calculate area. Like that's crazy. That's craziness. But yeah, you'll see in the industry that it's actually worth it. So let me use my calculator here. 985203 plus 260 plus 200. Yeah, it's exactly that. So it's correct. So as you can see, our class works. Our design pattern works, right? So if you want to add a new shape, do you see that how it becomes actually very easy? You just simply right click here and you add a new. You see that it doesn't affect the code. Let's go through it one by one. How do you add a new shape? Remember, the visitor does a visit, so we'll pass all the things we are visiting. That means there's a new visitable, right? That means I'll have to come here and add a new visit function. But do you see that it doesn't affect rectangle, it doesn't affect circle, it doesn't affect square. Square, they're not touched. That means my application can still work for those users who are still using only circles, rectangles, and squares. That's the point that design patterns was trying to raise. And then I go to shape area here. I simply override the other method. Do you see that it doesn't affect all the other visit methods? That it doesn't affect them in any way whatsoever. I just simply add this new shape. So let's do that now. Let's add a new shape. We have a rectangle. I forgot the other shapes. Let me Google it. Let me check here on the phone. I'm gonna add a rhombus. Okay, okay, to be honest, there's no need. Let me not be extra. It's fine. You can, that's homework. Go try to experiment and add other visitables. That'll be your homework. Yeah, you should go add other visitables. So this is basically it. So our circle, rectangle, and square, these are the concrete visitables, the things that we are visiting. And then we have the visitor, we have the abstract visitor, which is the abstract class where we declare the abstract methods that will visit each of the concrete visitables. So I hope it kind of makes sense now. Yeah, I know it kind of looks like it's unnecessary a lot, but to be honest, right, sometimes some things, there's this deep code. They say that you don't connect. That's why okay, it's related to life advice. It says that don't beat yourself up too much and think that you're not like making progress or something like that because you can't see the future. He says that you can only connect the dots by looking backwards, not forward, because you can't predict the future, right? But you know your past. That's how you're able to 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 weed out any bad crops by simply looking at the behavior. Let's say, for example, you've been backstabbed before, maybe been used in relationships and stuff, right? You tend to see the patterns, right? And how are you able to see the pattern? By connecting the dots through looking backwards. So, like, the reason why I'm saying that in other words is that it might not make sense now, but in the future, when you're in the industry and you look backwards and you're like, oh, we did this thing com side to A. Oh, I understand why it's important now. So right now you might not understand why it's important, but just know it is important. So yeah, that's pretty much it. I'll have to save this and then send it to you guys. So let me see. I see no point, right, in continuing the way we're learning because we have no time. You guys are writing soon. What I would suggest we do is I'll go read the design pattern, do a model here, a UML before we implement it. Then we implement it and apply it to the problem. And then I explain it a bit, like what are the benefits of what are the costs and benefits of this design pattern, when to use it, just explain a bit of that so that you can understand. So I'm going to export this as a PNG, Cairo PNG, desktop, save. So I'll send the image to you guys in the group chat. So that's it for today's session. See you in the next session.